Okay, to get us started, welcome to everyone to our fireside chat. We're really lucky to have Jenna and Grace here, who have both been, and Abigail, who have all been very involved in the Climate Match course creation. So this really is a participant-driven event, so really encourage all of you to ask questions. We are using the Zoom webinar format, as you can see. There is a Q&A box. You should be able to see it at the bottom. So please type in your questions into that Q&A. Really encourage you, the earlier you ask them, the better. You can really ask on anything. It could be questions about the course content. We have Grace here. You'll be doing her day tomorrow. If you have any questions, or you'll be doing it today. If you have any questions on that content, Abigail and Jenna have been founders of Climate Match. So if you have questions around the origins, you can ask that. If you have questions around PhD applications or kind of what it looks like to go into a career in climate science, all those questions are really open for discussion. So really whatever is of interest to you all, encourage you to put those questions in the Q&A. We will be recording this event, so we will go ahead and post it in our Discord after it's over. But really, those are my only logistical things. So I'll stop sharing, and I think we can start with a round of introductions. So if you all want to share kind of who you are, what you're currently doing, and your involvement in Climate Match, that would be awesome. And let's see, I'll start with you, Jenna. You're kind of at the top of my screen, and then we can go Abigail and then Grace.
Hello, everyone. My name is Jenna Pearson. I'm a co-founder of Climate Match with Abigail, and I've been the course director for the last 2 years. So you may have seen me popping into Discord a few times this year. It's great to be here. Thanks for coming. How about Abigail can go next, I guess.
Yeah, hi everyone. I'm Abigail Bodner. I'm an assistant professor at MIT. I work on climate modeling and ocean dynamics and some machine learning, trying to kind of understand the role of the upper ocean in the climate system. I was also one of the co-founders of Climate Match Academy, and I served as the executive director in the first year. And yeah, I've been kind of involved more on the higher level at this point, on the board of Neuromatch, but I'm very excited to see new climate scientists joining our course.
I'm Grace Lindsay. I'm an assistant professor of data science and psychology at NYU. I have a kind of complicated path to being connected to climate match and climate change. My background is in computational neuroscience, and so with respect to neuromatch or science match, as it's called, I was on the founding team of the first Neuromatch Academy in 2020. And I've also done a content day for the Neuro AI course. But for this course, I was the day lead for this day, week 2, day 4 on climate and AI or machine learning. And so right now I have research in my lab that is related to applying machine learning to satellite imagery and remote sensing to study a variety of things related to climate change mitigation and adaptation.
Awesome. Thank you all for introducing yourself. So again, really encouraging the folks that are here to drop some questions in the chat. Definitely more fun if we hear from you, but we can kind of keep the conversation going. We are approaching sort of the end of the course. I'm curious, probably especially for Jenna and Abigail, are there things that you hope the students were able to get out of the course? And do you have any kind of tips or thoughts on where they should go next? Kind of now they've taken this course, what advice do you have to the students as they continue their journeys?
I could go first on that. So I'm just excited that you all made it, first of all. It's a very intensive course and it takes a lot of grit to get through it, to be honest. So we're excited that it's nearing the end and we've got so many people that are still engaged and excited about climate science. For next steps, honestly, I think thinking about our Impact Scholar program is just like a really solid way. And honestly, if you're someone like Grace, maybe thinking about our computational neuroscience class would be a thing too. We've got lots of we have lots of overlaps between the fields that are emerging, so it's kind of a a natural next step to think about what to do in that line. Abby?
Yeah, so I echo Jenna. The course was very it taught a lot of tools. You have now a lot of access to different sources of data and different topics within like the climate science, climate modeling, AI sphere related to climate science. And the Impact Scholars Program is really an opportunity to implement these tools in something that you really care about. And up until now, it was more about kind of what knowledge is out there that can allow you to gain these skills. But now it's really time to implement those skills into a project that would interest you and get you even further. So I think that that's a really great opportunity, as well as branching out to other courses within Neuromatch that could be more related to AI, for example, and see how those two blend together.
Awesome. Yeah, thank you. Yeah, great reminder about the Impact Scholars Program. Viviana should be posting some reminders about that on Discord. And when you submit your project proposal, you'll also be able to say that your team is interested or someone within your team would be interested. So it's a great, yes, a great promo. I'm curious, Grace, I feel like Abigail and Jenna both touched on it, and you said it yourself. You kind of changed fields a little bit or found yourself kind of in different areas. I know that a lot of our students come from very diverse backgrounds. They're not all climate science focused. So would you mind sharing a little bit about your journey and how you ended up more focused on climate science, starting from more of a neuro background?
Yeah, so I did my PhD as well as a postdoc in computational neuroscience. And I was and still am, because my lab is now split between two topics, focused on understanding vision. And so I ended up using a lot of techniques that overlap with computer vision to build models of the visual system. And then when it was coming time to finish my postdoc, I just decided I wanted, as just like an informed citizen, to know more about climate change and like what's the future going to look like? How should I be planning my life? And obviously, when you look into the facts, it's very scary. And so there was a sense that I needed to take action on that. And so it took me a while to pinpoint exactly how I wanted that to show up. But I ended up deciding that I wanted to use the machine learning skills that I had, the computer vision skills that I had, and apply them to climate change related problems. And one domain where that's really straightforward is analyzing satellite imagery. And so that's kind of where my research is, and using machine learning to analyze satellite imagery for a variety of climate change related problems. Because I'm a professor of both data science and psychology, I kind of get to have this weird split. Obviously, most people, if they're thinking about like switching up their career or their path, especially at a younger age, it's probably better to like fully pivot to something else. So for example, when I was in undergrad, this isn't quite as big of a pivot, but I started wanting to be a pure experimental neuroscientist. And then I learned about computational methods, and it did require some pivot in coursework and a lot of pivot in like self-identity, actually. Yeah, so certainly when you're younger, it's like, it is still a pivot if you started studying something else and you change, but in some ways, it can be a lot easier, or there's not as much inertia behind you to keep you on the path that you've been on. And so it should definitely be possible to pivot, and especially in cases where you can identify overlap in the skill set from what you already know to what you want to be doing. That really helps build the bridge. And then from there, you can even, go off and do different things that aren't related to the original skill set. But in terms of getting started, finding some point of overlap usually makes it a lot easier.
Yeah, definitely. I know in one of our other fireside chats, they talked a lot about, making those changes, but you still have to have some connection and kind of overlap in skill set. So yeah, I think that makes a lot of sense. Thanks for sharing that. I'm curious for Jenna and Abigail if each of you would want to share a little bit more about your kind of path to your current roles for the students that have been joining us. Yeah, what has that looked like? Have you had any of those career pivots, maybe smaller than Grace's, but if you still want to share a little bit about those journeys?
Sure. So fun fact, Jenna and I were in grad school together. So she just happened to be my best friend, and we thought of kind of formulated climate match also together after that. So where you go to grad school could end up determining a lot of your future path and the people that you collaborate with also moving forward, even outside of academia. So
I found my husband in grad school.
did you? Oh yeah. And yeah. So that's kind of related to climate match, but I came from a math background actually. And I had an interest in earth sciences, and I found that oceanography or physical oceanography is kind of perfect match between like math and physics and the natural sciences. So I got really excited about being able to describe certain flows in the ocean by like equation that you can actually write them down. And over time, this got way more complicated, and I realized that I needed to get more into models and observations and machine learning, kind of to be able to leverage like everything that we can from kind of what we see and how we understand it. So I actually didn't know how to code at all until probably towards the middle or end of grad school. And that has really what has inspired Climate Match for me, because I feel like one of the major barriers that I faced was just being able to even make plots. Like I didn't know how to do that. I didn't know how to access, data. I didn't know how to visualize it. Like it was super basic for me. And I think especially, in a world of a changing climate, when we are seeing things going on, we don't really understand what are we supposed to be looking at? What does that mean for us? So hopefully by providing these tools for a large population all over the world, people can then have the skills that they need to really understand what that means for their local community, but also in terms of professional development and career. It means that you now have the skills that you need in order to, take this knowledge to the next step.
And thanks, Abby. So I have also a kind of a winding path, and I started off a little bit like Abby and more in math than anything else in undergrad, and that was also kind of I started out doing biology and then pivoted to math when I realized that I had like a talent for it. And then I deployed actually in the middle of my undergrad overseas. I was a medic in the Army, and during that time, I was still taking some courses online and talking with my advisors. And I was just thinking about ways in which I could apply my math skills to deal with public health, like global health disparities, that kind of thing. And we didn't really have a solid like public health program or anything like that at my school. And so he recommended I consider earth science as a way to kind of, there's lots of transferable skills from earth science to public health. And so he kind of recommended that I take a look into that. And I was like, that sounds great. I really enjoyed it. And then from there, at grad school, where it was with Abby and also my future husband, he was a postdoc, I was a grad student, just kind of blossomed into oceanography as well. And it definitely was not something, there was really no plan to a lot of this, I must admit. It just kind of the right things kind of happened at the right times. And I met the right people, and like everything kind of fell into place from there, which was pretty fortunate. And I think that I think that from there, just kind of made my way over to Climate Match. I was just about to have my first child when Climate Match came together, and so I took a little bit of a hiatus and then came back, and I've been along for the ride, ever since. And that's where we are.
Awesome. Yeah. Thank you both. And yeah, I think it we know the diversity of our students that folks often don't come to Climate Match with specifically a climate science degree behind them. So I think really this shows that you can kind of come into this area from so many different ways. I know that one of the big focuses for the course, and something that was really crucial when creating the Climate Match course, was this idea of data to action. So not just learning about how to do those plots, but also what do you do with them after. So I'm really curious for each of you, what does that data to action piece mean, especially in terms of the climate space? So let's see, Grace, we'll start with you on this one.
Yeah, especially since, I'm coming to this more from a data science angle than like a first principles basic science angle. All of my research projects on the climate side in my lab, we partner with some other organization that has some sort of problem, data related problem that it would help them if we solved it. So that helps me feel like what I'm doing will actually have impact, and will lead to some sort of change. Maybe I can give an example. I have a project now where we're trying to track the impact of beaver dams on vegetation surrounding them using satellite imagery. And through that, I've talked to a lot of people in like land management, people who do, there's a trend of reintroducing beavers to do restoration in streams. And just learning about like they have a hard time actually tracking the impact of their projects. It's very intensive if you want someone to like go to each dam site and document the changes over time, whereas from satellite imagery, we can get like a general trend over time without needing anyone out there. So yeah, I try to have everything kind of connected and embedded in all the work is motivated by some sort of outcome.
Yeah, that's really cool. Yeah, a great example of that, like civic science and use of community partners. So awesome. Abigail, do you want to go next?
Sure. I think my work is a little less applied locally. It's more that I think of it the other way around. I think about local small scale physics, for example, and how they impact the globe. So it's kind of indirectly related to climate change in the sense that I focus a lot on improving climate models on the scales that they are not resolved in climate models. So there's a lot of processes like so beaver dams would be something, for example, that's not resolved in a climate model, but yet it might have an impact on vegetation. And then through the vegetation, you would then see an impact on kind of the average global vegetation, and then that would impact CO2 projections into the future. For the ocean, it's comes in through the way it interacts with the atmosphere and the way you can uptake, for instance, heat and carbon, and other fields that are impactful for projecting climate change into the future. So I think more about how to better understand those processes and how do you simplify them and quantify them in a global model. And then those global models can then be used to project, for instance, temperature 100 years into the future, and then all the downstream tasks on local communities. So it's somewhat of a reverse process. But that's why I get so excited about the Climate Match Academy community, because that kind of brings me back through the back door, and allows me to interact with people that are then getting the data of these future projections and thinking about how that could impact, for instance, vegetation and extreme events, and so on and so on. So it's a kind of coupled system.
Awesome. Yeah, thanks for sharing that. Yeah, I like the very kind of different perspectives. So that's awesome. Jenna, do you want to add to that question as well?
Sure, I'll try and be a little brief. I see we have a question in the chat and in the Q&A, so we can get to those in just a sec. So data action is really super important to me in terms of how we structure the course, because really for two reasons. One, I personally in my PhD, I found that the work I was doing didn't really have that impact factor that I was kind of, like that was really helpful for like motivation, when you're down in the weeds and stuff, knowing that it means something at the end of the day was important to me. And it took me a while to get there. And I didn't really feel like until my postdoc that I kind of got that like more like like I knew I was doing something meaningful in my PhD. It's just in my postdoc, it felt like it was more like not instantaneous gratification kind of thing, but like it was more present. It felt real to me. Like I was doing something that was affecting like some family who lived on the coast of India or something like that. So I think it was really important to like help and make sure that the work you feel like the work you're doing is meaningful, which is a really important I think driver for a lot of folks out there. The other thing is just right, data action is important because there's no time for just data anymore. We really only have action. Like it has to be together at this point with the way things have gone over the last, 30 to 50 years and the way they look like they might be moving a little bit to the future. We really need to make sure that um, we're not just, looking at the data, we're actually using it to make meaningful changes in the world. So thanks.
Yeah, thanks. And I know that during the course, students did at least one of the impact talks. So I think that's really related to this concept as well. So thinking about, I know we have a climate justice one. I know there's one on socioeconomic experience around climate. So those are also, I think, really important as part of this conversation around data to action. So we did get a question in the chat for you, Grace. So I'm going to kind of come back to your answer around use of satellite data. So as you mentioned, you work with satellite imagery. As you know, satellite images are not always high resolution. I wonder how you deal with low resolution satellite images. So if you could share a little bit about how you do that.
Yeah, it's always kind of a back and forth of kind of defining your problem to be able to be solved with the resolution that's available. And, also trying to seek out better resolution or better methods for analyzing low resolution data. So, for example, in the Beaver Dam case, we're using Sentinel imagery, which has a 10-meter resolution, which is fine for seeing like large changes in vegetation. Just if like more vegetation is surrounding the beaver dam, we can pick that up, or the intensity of the vegetation via these indices like NDVI. So for that problem, that's fine. There is also the option in the US of this NAPE imagery, which is flyover imagery that has like 1 meter resolution per pixel. So, but it's only taken like every 2 years. And so there's usually like a trade-off between how the temporal frequency and the spatial resolution. And so you have to sometimes combine different sources to get different things. We have to also use Landsat because we want to know temperature, and Sentinel doesn't give you like a good temperature signal. So it's about kind of piecing things together. I have a different project that's about trying to map solar panels. And for that, we're actually using the Google Maps API because that has down to like 0.15 meter, 0.3 meter resolution. But obviously there's a lot more limitations on it. It's kind of just like whatever Google wants to give you, and it's not always the same resolution, and you don't really know what date it comes from. It's just, this is the image that they think best represents this area, and that's what you get. So yeah, there's a lot of trade-offs, and there's a lot of kind of sometimes having to compromise on what exactly you hope to get out of the data because of the limitations of the data itself.
I can add to that a little bit too, because I have a similar problem in that the ocean scales I'm interested in often are in resolutions that cannot be captured by satellites. And there's kind of a new satellite that came out that everyone's really excited about that's kind of providing the highest resolution of ocean sea surface height for the first time. But it repeats the same location every 21 days. So on the one hand, you get very high resolution data, but the processes that you're interested in don't last that long. So by the time you're back, they're gone. So we're thinking about how we can use different forms of machine learning and AI in order to fill in the temporal gaps and to try to get kind of a continuous data set, or also like do some sort of super resolution between combining different types of other satellites in the same way that Grace is approaching this in order to kind of highlight the physical processes that we want when we don't have the data. So it's really tricky, but it's also it becomes a very exciting data science problem when you think about it, is how you can get the data you need to then do the science you want to do.
Awesome. Yeah, thank you both for sharing more about that question. We did have a question as well around PhD applications. So I'm curious if all of you or any of you in particular want to share a little bit about what it looks like to have a competitive PhD application. I know that you all are based in the US, so probably US specific, but I think any general tips are awesome. So, and anyone's welcome to jump in on this one.
I mean, I can speak from the side of reviewing PhD applications. I guess just to briefly say the difference. In the US, you usually come in without, or you don't have to have had a master's degree, and then it's like a 5-year program where you do a master's and research all in one, whereas in other places, sometimes a master's is separate and the PhD is just like 3 years, and it's for a more pre-specified project that you'd be applying to. So there are some differences in how that would work for the application. But yeah, in the US system, usually what we're looking for are, for the climate stuff, people would be applying for me, the data science PhD program, which is obviously kind of different than if you were applying through an earth sciences program or something like that. But if you're looking to do kind of quantitative methods or machine learning, then you want to see that strong quantitative background, experience with that, grades and relevant courses. And the other thing is a demonstrated interest in the topic matter. So either having done some research already, or at least have taken relevant coursework that's related to kind of the climate related topic that you're interested in, all of those kinds of things. One thing that I sometimes see, maybe this is specific for data science applications, but sometimes people try to be really like broad, like I'm interested in all of the data science topics and all of the applications. And I think the hope there is like you cast a big net and some professor will be like, yes, I'll take that person. But for a PhD, it's a deep, intensive experience, and you need to be sure that you want to study that topic. You want to devote a large portion of your life to that topic. And so in a PhD application, I want to see signs that this is someone who will be enthusiastic about a somewhat niche topic for many years to come. And so that means having demonstrated interest in that already, writing a statement that isn't overly broad, that kind of defines some sort of sub area that you're actually focused on, meaning you're willing to kind of let other people say, oh, this person isn't for me because they're focused on that thing, not trying to please everyone at once in the application. And again, it's different programs work differently, but sometimes you're admitted into a program and then you figure out the professor you're working with. Sometimes you try to get directly with the professor from the start. But yeah, so sometimes the applications look a little different because you are kind of applying to multiple professors at once, but you should still be able to identify some solid theme that you can prove that you've been interested in this for a while.
Yeah, I don't have a lot to add. That was really great. I will maybe just say that it's also about the fit with a certain professor. So if you are interested in working with a certain person and you are interested in that niche topic, definitely build on that in the application and make sure you make the connections with existing work and kind of how the experience that you have gained already can contribute to that lab and what you want to learn from that professor also during your studies. And I think that that will make a very compelling story. I personally don't feel like there's a huge bias to which institution people are applying from. Like that was mentioned, I can't see the question anymore, but that was mentioned before about coming from, quote, a good university. Like I think it's really about the fit and about the skills and about the motivation. And if you can bring that forward in the application, then that will tell a compelling story. One thing I should also just mention is that sometimes people reach out to professors over the summer before the applications are due. Not everyone responds to those, so if you don't get an answer, don't be upset, but some people do, and they form a conversation, and then that can help guide you a little more to whether or not you would be a good fit for this person or this program.
Yeah, I generally have a policy of not chatting with people before the application because part of the application process, if you make it past the first stage, is you get to have interviews with professors, and it would just be kind of overwhelming and potentially biasing in my mind to be talking to people beforehand. So yeah, definitely don't be offended if a professor says they're not going to chat with you beforehand. It doesn't mean that you don't have a shot at the application necessarily. This is unfortunate, but because of AI, like chatbots, the statements themselves become less differentiating in terms of just being able to speak about a topic. And that's why the experiences like doing Climate Match matter more, because that's like true proof that you cared about this long before you sat down to write this statement. Because unfortunately now anyone can write a statement that makes it seem like they've really been paying attention to a research area. Whereas, you know, the actual experiences make it more clear that that's true.
Yeah, Jenna, I saw you come off mute. Did you want to add to this discussion?
I just have like two comments coming off of what Abby was talking about, being like from a good school and stuff. I actually wasn't from what you consider a good school from undergrad at all. I was like you know, a returning adult kind of, you know, not community college kind of level here, but like, you know, nothing like prestigious or something like that. And I think it was truly about, it was more about my application and my skills and my, you know, I was able to connect with people, professors that I was applying to their labs before I actually applied and those kind of things. And it, I think that did help. It also helped me a lot because it made me learn I did not want to work with some of those people that I thought I did just based off of their work, you know, their research alone. It gives you a little bit of an insight into what kind of person they are and how they run their labs and deal with their grad students. And there are some people that you just based on your own personality and your own, you know, like values and what you're trying to get out of a PhD that you'll just fit better with, and some that you won't fit as well with. And so I did find that part of it to be a little bit helpful and maybe, you know, can, you know, help me make the decisions a little bit easier when it came time to actually deciding to where to go. And as Grace mentioned, you do get the opportunity to interface with folks, you know, like after the application stage. If you, you know, if you make it past that stage, you will get that opportunity. But I felt like in particular, I was like well prepared also for for what to expect for those kind of things too. And so yeah. Um, just to keep in mind that it doesn't necessarily matter where you come from, it's what you've done and who you are that really does matter. And so I would say be bold. I actually had people tell me I shouldn't bother applying to some of the schools I did, including the one I ended up going to, because they're like, there's no way you're getting in. There's no, you know, and it worked out, you know, and I think that you shouldn't let that be discouraging by any means.
Yeah, thanks, Jenna. Yeah, I'd love to pull on a thread that a lot of you touched on, but yes, applying to programs is important, but I also think it's so important that students really are picking good mentors as well. So kind of that opposite direction, how are students and prospective students able to really understand who's going to be a good mentor? Is it going to be a good fit? I'm curious if you all have other tips on kind of when students are applying, how can they make sure they're going into a good lab that's a good fit for them. Their mentor's going to, you know, care about them. What tips do you have on that side as well? I think, yeah, Abigail or Grace, maybe if you want to add on. I feel like Jenna, you shared a little bit.
Yeah, so in terms of topic area fit, I think reading their papers is good. You know, the papers are maybe like a little bit of a laggy indicator of what they're interested in, but roughly the direction. And then in terms of like lab fit, you know, that's about actually talking to the professor during interviews and talking to the other people in the lab and asking them their opinion. And, you know, if the interview setup is done well, there should be a time for you to talk to lab members in the absence of the PI. And so that's usually how you're going to get the most information, probably.
And there are also different kinds of mentors that are not only the PI. Like there, you could have a mentor from your previous program that continues to be in your life and provides, you know, some support. And you could have a lab mate that's in your lab that's more senior that could be a mentor to some extent. So different labs have different structures. Some advisors are very busy and they could have 30 people in the lab and you might not interact with them as much, but there's some sort of structure that allows you to interact with others. So I just support Grace in saying like you need to make sure you know what you're getting into and if it's less ideal, but there's still like some support, then that could be something that is a decision that is made or you know, finding someone that's the style of advisor that you're looking for. But generally, I would say find someone that supports you for what you're interested in, that you're not just coming in to, do some sort of, job. It's academia, gives you some sort of intellectual freedom where you get to think about what you're interested in, what your pathway is, and you want someone to support you in that journey.
Yeah, great tips. Yeah, I think especially the talking with current students and former students. Yes, I'd say I always feel like you can ask a PI for contacts for former students as well. They should be open to giving you that kind of information. So yeah, that's great. I'm going to switch us gears a little bit. We do have a question in our Q&A that's a little bit more kind of topic specific. But so anonymous attendee shared, I have a background in civil and environmental engineering and have a well-developed experience in implementing ML and remote sensing to model water reservoirs, excuse me. On the other hand, I'm enthusiastic about Arctic studies, but I can't find the right gate to enter this dimension. Curious if any of you have any kind of insights or thoughts on that. I know we do have an Arctic ice project that I don't think we're not doing it this year, but I know we have had folks involved in that. But yeah, do any of you have insights into that area of study within climate?
I think the kind of echoing the things that were said earlier, one practical piece of advice would be to try to gain some sort of experience related to that interest. And it could be something even very small, but then that would be a gateway to then build on that and do something bigger, specifically if it's, grad school or something like that. But another way to go about this is to use the skills in ML and then apply that to this new domain. And then having that be the bridge.
Yeah, I mean, I don't know that much about Arctic studies, but it sounds like you would use satellite imagery to track the size and shape of things, right? So this feels like not, I went from neuroscience to climate stuff, so this feels like not too much of a shift if you can still be analyzing satellite imagery to contribute, and that at least helps you, move in that direction, and then from there, you can change to other things. So yeah, not knowing enough about the target field, it like there is overlap here in the skill set that's used.
Yeah, Jenna, I saw you just posted a mailing list. Do you want to share a little bit about what that list is?
Sure. I don't do anything like cryosphere side myself, like ice, glaciers, all that kind of thing. But if you're trying to get into the Arctic community, you might find some opportunities to gain some experiences there. For example, we posted about Climate Match on this mailing list, and there are other opportunities that come available. I would also kind of echo Grace in that if you're applying similar skills to answer a different problem, you might that doesn't seem like quite as huge of a shift as just, complete as maybe learning new skills in a different problem for sure. But I think maybe trying to isolate some folks who kind of have done that or do what you're interested in and, getting in those. I know people have reached out about that are just kind of doing something I've done in the past, even though I don't really do research anymore or anything like that. They still have just emailed me and I've responded. And so I might have a little bit more time than all of everyone else that's doing all of this, the full-time research and that sort of thing. But it's also worth reaching out to people if you really want some, if you're trying to break into that and just see, maybe they have advice on how they got started, or maybe they have a summer opportunity or something like that, or an internship. I know a couple of our people in some of my labs have started off as interns and made it all the way through their PhD in the same lab. So it's a possibility to consider that kind of thing. And I don't know how, I think in other parts of the world, it's a little bit more common to maybe take that route. But I know here it happens too in the US.
Yeah, thank you all. Let's see, I'm curious for our panelists, do any of you have kind of questions you want to offer to the group to kind of continue our discussion?
I can go first. Oh, sorry, go ahead, Abby.
My question is going to be sad. So if you want to,
It's okay, go for it, Grace.
I just wanted to know if any of the data sets that were previously used for the course were not available because the government of the US had taken them down.
Not to my knowledge, actually, from how we dodged that bullet a little bit with our data sets. Yeah, I think that everything that we were using is we've heard some links change for the remote sensing day. But I haven't heard, I don't know, Courtney, if you've heard any tickets or anything about just data sets just purely missing.
I think we have been okay. Yeah, we have been impacted in some of our Open Ed Science course more around some of that stuff, but I think our data sets for the climate source class have been okay. So let's see, Jenna, did you have a question for the group?
Yeah, I hope it's fine if it's for the like students and TAs that might be here instead of just the panelists, but just kind of I'm interested to know a little bit about what our students are and TAs are just kind of looking to get out of the course themselves. Like that's really helpful for, guiding updates and kind of just it's nice to see in terms of feeling like something is meaningful. Hopefully that you all are getting something out of this course too. So if maybe you could share in the chat if you're comfortable to do so, what you're hoping to get out of our course.
Yeah, definitely. I think as our students know, and yeah, please do share your thoughts on Jenna's question in the chat. And as the students and TAs know, we get a lot of survey data from our participants. So yes, we will definitely be reviewing that, but it's always helpful to have additional information and context to your experience and what you're looking to kind of forward thinking as well. I'm curious to, oh, go ahead, Jenna.
I was just gonna say, while folks are doing that, I guess a question for Abby or Grace would be like what reason, also maybe kind of a downer kind of question, but hopefully in a different way, but like what like recent, developments in climate science or like policies, those kind of things kind of give you hope around the world that like what are you excited about?
I feel like there's so much going on in the world right now that is dividing people, that because climate affects everyone, and everyone is affecting it, it gives me hope that we can build a community around this. And that's what we've done here at Climate Match, both in the course and in terms of volunteer base. But I feel like this is, a community that thinks about hope and thinks about togetherness and problem solving. And to me, that stands as something that we really need right now. So maybe it's not, a scientific problem we're tackling, but rather it's the science that's bringing us together. So that's what gives me hope.
Um, I, it's my understanding that tech around solar panels and batteries is like going pretty well. And actual use of those things, the economics are working out in places outside of the US more so, because the US is now actively disincentivizing that. But that gives me hope, because as much as I would like to believe that people will take action out of what they believe is right and good, it also matters that there's, the money is right as well. And so if solar panels can be a cheap way for people to get electricity, and even if they don't like the politics of it, they go off of that, then practically speaking, that works just as well.
Yeah, I might add to this one too, Jenna. I think too, just seeing the diversity of students, which I feel like I've talked about a lot in this panel, but looking at how many people are coming to this course who may or may not have had that much climate experience previously, but are really here because they're interested in pivoting their whole career or in finding ways they can take what they learned from the course back to their back to what they do, whether that's specifically a quote unquote climate science career or academic trajectory or not. I think that's really like hopeful to me that so many people are taking the time out of their life to, learn some of these new skills and have a better understanding so they can continue to share that wherever they're at. So.
I have a question for Grace. Since you have one foot in the NeuroMatch courses, and maybe for Courtney as well, what skills do you feel could be transferable from the Climate Match course to the other courses that NeuroMatch offers?
Yeah, I mean, I think there are, and I'm also a professor of data science, so I'm primed to believe that there are kind of universal skills that can be applied across different types of data. Um, I guess yeah, so there's like the meta skill or knowledge that domain knowledge is important, and like being humble when you come to a data set. And again, this might come from me like teaching data science students who are only trained, primarily in data science. And so I try to instill in them that like data is complicated. It comes from the real world, and you need to understand what people know about this process to be able to work with a data set. You can't just like treat it as numbers, right? So I think that's a transferable skill. In neuroscience, it shows up as like, oh, the person who collected this monkey ephys data, on Thursday, the power went out in the lab, and so there was an interruption for an hour, and then the monkey got mad, and that's why like the recordings are off for the rest of the day, or the monkey's performance is off for the rest of the day. Like it's weird things like that come up in data sets. In climate data sets, it's different things that you need to understand about the system or how the data is processed. So that general appreciation for data is a thing that comes from the real world, and you need to understand something about the real world to understand it. Definitely applies in both. The more hard skills, yeah, there are general things like linear regression or other kind of basic analysis steps, pre-processing steps like z-scoring and stuff like that. These are things that are used in many different fields. Obviously, I'm teaching the machine learning day, the AI day. Artificial neural networks are skill sets that are used across things. And the coding skills, of course, Python is used in both. So I think, yeah, there's some, there are the peculiarities of, like the neuroscience doesn't use X-ray or anything like that. But some of the things are going to be transferable. Knowing how to do Python and NumPy, you could figure out other things as well. So yeah, I think there's a decent amount, but having the domain knowledge is also important.
Yeah, I would definitely agree with Grace. I think some of those like core coding skills are shared, but then yeah, we know that climate uses a lot different Python libraries than our other courses do. There's a lot of climate specific ones. So yeah, stuff like that is different. I think each course has a slightly different but similar approach to projects. I think in both courses, you're going to really learn about creating a good project or research question and kind of the different methods around that, doing actual research. I think both of them focus on that a lot, probably in slightly different ways, but then the domain stuff is very different. So. Let's see. I think we have another question in our Q&A, so I might shift us to that. So Reza asked, I was wondering, as climate scientist, how do you guys keep yourself updated with the fast-paced progress within your field of interest? If your answer is reading scientific papers, is there a pattern in how often you actually look for new titles, or do you just read whatever comes to you? Yeah, it's a great question. Maybe Jenna, I don't know if you want to take that first, and we can kind of go around.
So to be honest, I'm not in the field as heavily anymore. And so to keep up with recent advancements, I often rely on other people in a lot of ways to share important, updates and just talking with people. Like, and hearing what they're doing and, kind of getting a pulse on things from that has been really helpful. And so if you, especially like I remember that similarly, I found conferences to be a more effective way to keep up with what's happening than papers. And I was not, and am still not a good paper reader. But I think going to me, I learned more by just going and listening to people give like a snapshot of what they're up to, a 5, 10 minute, overview of what's going on in different topics I was interested. And that to me felt, and they kind of like summarized kind of, in that case, people are kind of summarizing the like updates and status quo of things in their introductions and what they're bringing to the table, that kind of thing. And so I felt like that was a way. I definitely would made sure to take notes and write things down and sometimes even take pictures if it was just like a really good slide or something like that. And I felt like that was how I always ended up keeping up the most. And then, yeah, now I don't go to that many conferences or anything like that. So it's really just, the circle of folks I have and making an active effort um, to check out new things, mostly related to our course at the moment. But yeah, that's kind of now it's kind of a more active part on my end. But maybe Abigail, do you have any thoughts to add on that?
Yeah, I just want to say that I share the feeling of it being really overwhelming. I don't know if that goes away. At some point, you have a better idea of what you need to know rather than just like everything. Um, I highly recommend a program called Zotero. I'll put it in the chat. It's really helpful to organize literature based on different topics or projects you're working on. And that way it feels like it can be a little more manageable to just put things in like the bin they need to be in. And like I'm not working on this project this month. I'll get back to it next month, but that paper is still there. Or I'm going to make my way through this literature because I need it for this coursework, or I need this for this, this other paper I'm writing, and it kind of helps you keep things more organized. So that's been for me really helpful. And also organizing friends or your lab around like seminar reading or discussions during summer, like that's a really great time to do that, or during breaks to just walk through certain types of literature once a week or so together and talk about it and hash it out in a safe space where you can say you don't understand things. I think that's really helpful.
Yeah, this is a core problem for all scientists. But yeah, so I have some Google Scholar alerts. You can set up either topic like keywords or people you want to follow, and you get an email whenever they publish a new paper. That process also ends up giving you emails with recommended papers. So Google's using some algorithm to decide what they think you care about based on the alerts you already have and things you read. So that can help. Social media. I'm on Blue Sky. People are posting their papers. There's also bots that post papers that were posted to like Archive or BioArchive or any of the other archives. So you just get like a stream of papers that were recently posted. Um, and yeah, conferences are good because you get a lot quickly and it's like, up to date. But obviously they're, time and money consuming. So for climate stuff, at least related to things that I do, Climate Change AI has it's an organization that hosts a bunch of workshops at machine learning conferences. And those workshops are usually live streamed or the videos are available afterwards. And so that's a way that like anyone can kind of swoop in and see a bunch of talks in that topic area and then, feel a little bit more up to date on what's going on.
Awesome. Yeah, thank you. I think I'll close out with the last question we had in our Q&A. There was a question on recommendation for a book from each of you. So if you have maybe one or two books that were helpful in your career or just kind of in general that you liked. I saw that Abigail, you shared yours in the chat. So maybe do you want to go first and I'll give Grace and Jenna a minute to think.
I'll just say Grace wrote a book. For me, I had a challenge with the writing. I still do. It's something that takes me much longer than it probably should. So these two books I put in the chat about scientific writing, and specifically how to kind of tackle that aspect, was really helpful for me.
Awesome. Thanks. Let's see. Grace, you want to go next?
I can try. Yes, like so specifically thinking about my pivot to climate work. I mean, honestly, I just got I don't know where it is now. There's this textbook up here, which is just an intro to remote sensing textbook. And so it's not so much about that specific book, but more about the idea that if you were trying to start a new field, like yes, the internet is full of ways to teach yourself things and papers to read, but sometimes just like finding a good textbook and just committing yourself to like, I'm just going to go through this textbook and like, you don't have to do all the exercises or anything. Like it's not a course, but like it can feel a lot more calming to just be like, I'm going to learn what someone decided were the important things to learn. And I'm going to do it just by going through this book and not like getting overwhelmed by how many other things I could potentially be learning right now. So maybe it's just a general plug for textbooks.
I feel like we don't get that often, so yeah, that's a good good plug. Jenna, do you want to share one?
Yeah, so I went a little bit more specific. This is and put a book that was really helpful in my probably I wish it's a book I wish I would have had very much earlier on in my studies that I really enjoyed it kind of for in terms of like a climate science perspective, like the kind of ocean dynamics and carbon cycle. It's a very good mesh of all of the things that I was working on and where I wanted to go. And it did it in a way that wasn't incredibly overwhelming and but also was gave you everything you need to know and the math was there and that kind of thing. But just well thought out, well explained, and not like a huge book either. So
Awesome. Well, thank you all. I appreciate that those were all very different recommendations. So, yeah, thank you. Yeah, thank you for everyone that attended. I am going to share a quick slide. As you know, we do love our data, so please let us know what you thought about our panel today, what we could improve. Do you want to see more events like this? So I put the link in the chat as well. And I just want to say thank you to Jenna, Grace, and Abigail for taking the time to be with us today and to share some great advice. Yeah, just so much appreciation from me and from our students and TAs who also are here today. So thank you all. And yeah, we'll see you in Discord. Good luck on your last day or last 2 days, depending on which time slot you're at. So you're almost done. We're excited for project presentations and closing ceremonies tomorrow. So thank you again, and I hope you all have a great rest of your day.
Thank you all for being here, and thank you, Courtney, for bye everyone.
Bye.